a P point here, APL, okay, has the points 0, 0 at A, 0, 0 at the vertex. This is at the vertex here, and L, AE, B square upon A. This we know about. This is twice B square upon A, total length of the this lattice rectum LB L dash, which is twice B square upon A square. So half will be B square upon A, B square upon A only. Therefore, but here B square is equal to A square. Therefore, this value we have taken E is equal to under root 2, which we have calculated here as B square is equal to A square into E square minus 1 in case of hyperbola. This implies that this E is equal to under root 2. Therefore, the coordinates now. Therefore, the coordinates of ending point L of lattice rectum will be now E is under root 2, so this is A root 2 into B square upon A. That means A square upon A means A only. Try to understand. As B square upon A is equal to A square upon A equal to A only. Okay, this B square upon A. So these are new coordinates now. A under root 2 and A. So let me write these coordinates there. So what is the coordinates here? Finally, so we have to find out the surface generated. It says surface swept out by. Find the area of the surface. So area of the surface we have to find out. Let me find out. So new coordinates are. So here coordinate is A under root 2. Let me write now. And this is now A, only A. 0, 0, 2, A under root 2A. So now coordinates of, if I take this point from this to this point, or x coordinate from this point, so this will be 0 to A under root 2 for x coordinates. What is the surface generated? Therefore, area of the surface. Now, area of the surface generated by revolving arc APL about the x-axis, is given by only this much here. This is limit 0 to now A under root 2. This is x equal to 0 here, and here it is A under root 2. So 2 pi into by into ds. Okay. Now this is, or here we have to put here dx, not ds. Here it is dx. Or if we write dx here, this is ds. What we have to find out? And the surface area only, pi into dx. This is revolving about this. So this is y here, coordinates of this y coordinate, but y here is at a. So y, let me put what is the value of y from this equation given. So it will give us limits, because x coordinates are given with respect to x. We have to integrate this. This is okay about this line. If I take a P point here and drop a perpendicular from this point to this, and this is P point here. This is dx here. This is y coordinate of this P here. So by dx, twice pi dx, this we know about. 0 to A under root 2, twice pi, let me take outside. Now y is from this given equation. Here y square is equal to y square taken to the side, is x square minus a square. Try to understand. or y equal to under root of x square minus a square. This is nothing but x square minus a square into dx, half power square root of this whole into dx. Just integrate this. Let me integrate this. That will give us the integration. Therefore, surface area S we are calculating 2 pi limits 0 to a under root 2. Okay, only one arc we have to find out. If it is double of this, then this also will be taken, so twice we can multiply. But in this case, it says on the area of the surface swept out by the arc of the rectangular hyperbola, this extending from the vertex to end of the its rectangle. Okay, so this is the value here. So let me now integrate this. So this is x square minus a square. X square minus a square whole power under root of this whole into dx. What is the integration of this? This is now x square minus a square, not a square minus x square. Then it will be in terms of, it is twice pi. It will be integration 1.2x under root x square minus a square plus this is 1.2 a square log of, within bracket it will be x plus under root x square minus a square. These whole limits are now 0 to a under root 2. So substituting this value, is there answer given to us? No, answer is not given. So after substituting the limits, this integration of this value. Okay, so that will give us the final answer. The final answer is that value. So it is coming out as, okay, the same thing is there. So we have just calculated the same thing. This is twice x square. But here dx upon dt, I'm sorry, because this is not dx, but it will be ds here. It is, I'm sorry, it is not this type of question here. It's not, I've taken this mistake only. This is ds here, I'm sorry. So ds we have to calculate first. This is 2 pi y into ds integration 0 to a under root 2 we have taken. This is ds here. But ds upon dx into dx we have to write. So that value can be written as ds upon dx into dx. I'm sorry. This ds upon dx. First I was writing this. So this is in case of surface area. This s is length here, arc length. This is ds here. This surface area. I'm sorry. We do not take this ds. This ds we take. In case of surface area, we calculated. Okay. In case of volume of surface area of revolution. In that case, we took this ds only. So this is ds upon dx into dx. What is ds upon dx here? So ds upon dx we know this is under root 1 plus dy upon dx whole square. So what is this value? It will come out as 1 plus dy upon dx from this equation. If I find out, it will give us x upon y. Why? Because x square is equal to y square plus a square. If I find out this is twice x equal to 2 by d by dx from first equation. Therefore, this is from first equation, from first here. Therefore, this 2 cancel out. So by dy upon dx is x upon y. So this is x square upon y square. This is giving us x upon y. That means x upon y whole square. That means x square upon y square. It will give us total value x square plus y square in the numerator upon y square. So what does it give us? This is a square in the numerator. So this is under root x square. Sorry, x square plus y square is not a square, but this is y square. If I substitute, that will give us x square minus a square. That will give us x square plus x square minus a square in the numerator divided by x square minus a square in the denominator. So finally, what do we get? So I'm sorry, this value we obtain here is ds upon dx we are calculating. This we have to substitute here. I'm sorry. So this is ds upon dx. We have to calculate here. That means this will give us twice x square minus a square in the numerator divided by x square minus a square. So this we can write as under root of twice x square minus a square upon under root of x square minus a square. Now if I substitute this value of ds upon dx here, what will it give us? Let me now substitute this value here. Total surface area twice pi, let me take outside, this is 0 to a under root 2. Now under root this value of y is x square minus a square into ds upon dx is this value, which is under root twice x square minus a square divided by under root x square minus a square into dx. Now this value cancelled out. Here we are left with under root 2x square minus a square into dx only. This we have to integrate. Now let me write it here. Okay, no problem. Now let me write it here. Therefore surface area equal to twice pi. This is sine of 20 to a under root 2. Now we have obtained twice x square minus a square into dx. I'm sorry, in place of dx we have to write ds only. So this is now arc length. When we revolve this arc length, this will give us twice pi by ds. Okay, ds here. ds is ds upon dx because we have to integrate it with respect to x. That is the value. Okay, this is the function. Now we have to integrate. This will give us twice pi. If I take 2 outside, it will come out as under root 2. 2 under root 2 here. It is 0 to a under root 2. What is the bracketed value? X square minus, it will be a square upon 2 or a upon root 2 whole square. It will be now into dx. Now we can integrate this. For the final integration, this is 2 under root 2 into pi. 2 under root 2 into pi. 0 to, sorry, now let me integrate this. For the integration of x square minus a square, as I just wrote it down, it is 1.2x under root. This is x square minus a upon root 2 whole square plus 1.2 a is this a square now. So it will be a square upon 2 only. The square of this, that means a square upon 2 log of, in bracket, let me write curly bracket here, x plus under root the same value, x square minus a upon root 2 whole square. Okay, now this is, now the limits are 0 to a under root 2. Let me now solve it here. Therefore final answer of this area, surface area, we are calculating here. Surface area is equal to, let me change this, not giving proper result. Surface area of this equation will be, now this is 2 root 2 pi we have taken, and this 2 and this 2 also we can take outside. So 2 is cancelled out, only under root 2 pi. This 2 will be cancelled out. Let me take this only under root 2 outside into pi. This 2 we have taken outside. Now x upper limit, this is a root 2. Under the square root, it will be now square in place of a, for the x we have to put a, that will be 2a square only. A under root 2 means 2a square. Under root 2 square is 2 and a square minus a square upon 2 in the square, in the bracket, sorry, plus 1 point, so 1 point a square upon 2 only. This is now a square could also be taken. Let me take, what is that? This is a square upon 2 here. Now log of this value. So if I write it here, let me write here what the value of log in the angle of log. So in the angle of log will be x means a under root 2 plus, from inside we will get 2a square, the same value, minus a square upon 2 This is the value. Minus sign now. If I substitute lower limit 0, that is 0, this value will be 0 because this is x into something, so 0 into something 0. Now only this log value will come out. So this is a square upon 2 here. Now this is log, it is 0, this is 0, this is minus sign, under root of, this is square root of, now a square upon minus a square upon 2. This value will be there. Okay, so now let me rub this. It is giving us, now this is final value. So under root 2 pi, if I take this root, okay, let me take outside, root 2 pi, here it is a root 2, and from inside, if I take a outside, so that will be a into root 2, and this is a square now. Okay, let me write it clearly. This is a under root 2. Now a from inside we have taken outside, so this will come out as a, so that is a square now. A square root 2. Then bracket under the square root, what will be the value? It is 2 minus 1.2. That means 3 by 2. It is nothing but 3 by 2 here. Okay, so this is 3 by 2. Okay, now plus sign here, a square upon 2, if I take out common, and this log m minus log n. Log m minus log n. That is, let me write here a square, sorry, we have taken out, still we have not taken outside, no problem. Log of this value, log of this upon this, under root of this value, minus a square upon 2. That can give us, this is under root 2 here. From this value, we will get our a is also there. Let me write within bracket plus sign. Now this is what? 4 minus 1 means 3. It will be under root 3 upon under root 2 in the numerator, divided by, now it will be minus a, minus, that means a, if I take minus 1 as I square, so it will be minus ai upon root 2, ai upon root 2, ai upon root 2 here. So this root 2 means 2 root 2, a cancelled out here, so I only, that means this is root 2 into pi, and to a square we can take now outside. This is under root 2 pi a square, this is root 2, and root 2 if I take outside, it will be 2 only. It is, let me take root 2 outside, this is root 2. Or from this root 2 and root 2 cancel out on root. Okay, if I take root 2 outside from denominator, this is root 2. So this root 2 multiplied to this root 6 will be there. It is root 2, then root 2 cancel out. So this is then pi a square. Or if I multiply this by root 2 inside, it is then 2 only, and this is then under root 2 into this. That will give us under root 6. Under root 6 here. This is plus sign. 1.2 here. Log of. Now this is 2 plus root 3 divided by this iota only, because under root 1 root 2 cancel out. This is only iota here, where iota is sphere is equal to minus 1. We know this iota is sphere. Root 2. This is the answer here. The question, this is this value. Or if I write log of iota, okay, that is not there, because under root a square upon 2 it was, so a cancelled out, only 1.2 minus 1.2 it was. And if I just not write minus sign here, then under root, if I take common, then it will be 1.2 here. 1.2 power will come out. This is minus 1. In case of negative value, it will be then minus sign here. So that will be then divided. So that minus sign, this one, if I take half power out, this will be 1.4. Because this is power half will come before. So minus a square upon 2. Okay, and that means negative sign it will be positive then. The minus sign can be taken outside. So positive sign, then multiplied, same value will be there. Okay, so this is iota I have taken. This is the answer here. So question number, surface area here. This is pi a square. Okay, a square is coming. That means it is under the square only. So this is surface area. This is the answer here. Final answer is this. Okay, so this is pi a square under root 6 and plus half log of that value under root 2 plus, sorry, 2 plus under root 3 divided by iota in this case. With iota square we have taken negative sign. Now 10th question. Now this question number 10. Let me check it. Now question number 10 is of what kind? It says, here it is 10th question. 10th question says find the volume and surface, you mean both the volume and surface we have to find out, of the solid generated by revolving the cycloid x equal to this. Okay, about its base. Okay, so about its base cycloid is there. Okay, so find the volume of the surface of the solid generated by revolving the cycloid a t plus sine t. This is the value. Question number 10 here. What is given to the cycloid? We are given here cycloid x equal to a into t sine t and y is equal to a into 1 plus cos t. A into 1 plus cos t. Alright. About its base. So about its base. Okay. So if I just substitute here, what is the cycloid of this cycloid here? Find the volume of the volume and surface, both volume and surface area of the solid generated by revolving the cycloid. This about its base. Okay. Let us take one by one. First volume we have to find out. First is the volume. So volume we have to find out. Okay, the marker is okay now. Not a problem here. Marker is okay. So here the cycloid is of what kind? Of this cycloid is, let me draw the cycloid here. If I put here, okay, y is equal to twice a when t is 0. At t equal to 0, here it is. Again, it will be a cycloid of this kind. This is a tangent line here. Let me draw tangent line here. This is also tangent line. Here, twice a at t equal to 0. And here t equal to minus pi. Because that minus pi, it is cos pi. Cos pi is minus 1, 1, 0. It is 0 here. So the curve comes out to the end. Here also t equal to 0. This we have drawn in one of the previous questions. Okay, this kind of, this is y and y dash, and this is y here. This is x-axis. About its base here. Base is this. We have to revolve this. So from 0 to here pi. Sorry, this is pi here. I'm sorry. Here t is pi. But pi also gives us minus 1. So 1 minus 1, 0. That means 0 here. The curve is from minus pi to plus pi. This whole curve is revolve about its base. This is the base here. Okay, so this is pi by square into dx. There's a point. We'll just calculate, but before that, let me take that. What is the value of this question is given here t. Okay, so t limits are from, if I take this half of this arc here, so this is from 0 to this. Let me write here points. This is suppose a point here. This is B point, and this is B dash point. Let me take this is O here, origin. So we have to find out first surface volume. If I have to find out volume, this arc is a revolve about base, this x-axis. X-axis is the base here, OX. So this, if I take limits from 0 to pi, then we have to make twice of this. If I take minus pi to plus pi, then this whole is taken. So let me take from 0 to pi and make twice of this. So volume generated will be Here the volume or surface area, volume generated by revolving arc AB. Here we can take theta equal to pi by 2, or here t is there. I'm sorry, not theta. T is equal to pi by 2. Here t is minus pi by 2. Here t is equal to minus pi by 2. In this way, we can draw the curve. Okay, this is the curve of the given cycloid. Now the volume is generated by this whole curve about the base axis. Base means axis of x. Base is axis of x. Points we have to take from this limit to this t points. Everything is converted into t, so we will take that. What is the volume of this? We know that volume of the this is given by the equation y is given there. So y square into dx here. Okay, because this is, if I take p point on this line, that will be p point here. P, and this is q point. This is about the x-axis, so it is y here. The whole is y, and this is dx here. Okay, but limits, everything is converted to t, so that is there. So dx upon dt is this value we will take for the volume here. Let me write that. The volume, here the volume generated by revolving the arc AB about the x-axis, base or x-axis, about the x-axis or base, is equal to, this is twice into total, this whole is revolved. So instead of taking this whole, we are taking limits 0 to pi. This is twice of, or we can take 2 times 0 to pi. Undoubtedly minus pi to pi, if I write, then twice of that gives us 0 to pi. Okay, so this is twice into 0 to pi, or twice into, first let me write volume, whole volume. This is about arc AB. So arc AB will give us 0 to pi limit here, 0 to pi. Okay, and this is pi into y square into dx. Pi into y square, this is pi, let me take outside, this is 0 to pi. Y square here is this value. This is a square into 1 plus cos t whole square into d, x can be written as dx upon dt into dt. This is volume of this arc only. So total volume of this whole cycloid will be twice of this. Okay, that is there. The pi a square into dx upon dt we have to still write. Pi a square into 1 plus cos t whole square into dx upon dt, if I write here. So dx upon dt, let me find out, differentiating it with respect to t, to give us 1 plus cos t. Again it has come out as a into 1 plus cos t into dt. Now dt. With respect to t, we have to now integrate, because limits are for t only, t0 to pi, 0 to pi here. Total volume we have to find out. Therefore, total volume generated by revolving the cycloid, by revolving the cycloid. Here cycloid, complete cycloid is revolved about base, about its base, means x-axis, is equal to twice, 2 times, 2 pi here in this case, 0 to pi into a square means a cube, let me take outside. This is now 1 plus cos t, 1 plus cos t whole cube into dt, 1 plus cos t whole cube into dt. What it gives us then it will give us, let me write further, it will give us total volume we are calculating. V is equal to twice pi a cube. 1 plus cos t, let me convert this into 1 plus cos t is 2 cos square t by 2, or 1.2 t whole cube into dt. What is this value finally? It will give us now why this formula is hence why since cos 2 theta is equal to 2 cos square theta minus 1. So 1 plus cos 2 theta is equal to cos square theta, but 1 plus cos theta is equal to 2 cos square theta by 2. Because of that we have written down this cos t by 2. So if I now substitute the limit t by 1.2 t, if I put phi, let me take, putting 1.2 t is equal to, let me take, theta, or t is equal to 2 theta. Therefore, dt is equal to twice d theta. Okay. Now it will be 2 times 8 will be there. 8 will be 16. It will be. First, let me convert this into 16. Let me write further. 16 pi a cube 0 to pi. Now this is cos 6 1.2 t into dt. This was the value. Here we have substituted 2 theta. This 2 t 1.2 t equals to theta. Now we have to substitute. It will give us twice theta, undoubtedly 2 d theta now. And limits, if I substitute limits, what are the limits? At theta equal to t is equal to pi, at t equal to pi, theta is equal to pi by 2. And at t equal to 0, lower limit, theta is also 0. And at t equal to, at t equal to 0, theta is also 0. So limits are now, this is now 32 because 2 d theta will come out to 2 into d theta. In place of dt, if I write to 2 to this 32 pi a q, 32 pi a q. Now limits are 0 to pi by 2. This is cos now 6 theta d theta. Try to understand. This is done. Now we can apply the reduction formula for cos. Let me further write it down. This is 32 pi a cube. Still I am writing the same thing, 0 to pi by 2. Now this is cos raised power 6 theta d theta. Okay. Now by reduction formula we know the reduction formula here. So by the reduction formula, the value of this will be 5 by 6, 3 by 4. What is the formula? If it is cos raised power n, and it will be n minus 1 upon n minus 3 upon n minus 2, and n minus again 5 upon